Hello everyone. In the previous video we have learnt about the elementary transformations or elementary operations on matrices. In this video we will learn about the application of the elementary transformations, that is to find out the inverse or multiplicative inverse of a matrix. Let's revise the concept of multiplicative inverse here. That inverse of a matrix is if we have any of the square matrix A, let A be a square matrix of order n into n and B be another matrix of same order such that A into B is equal to I is equal to B into A. The product of A and B is the identity or the unit matrix. Then we say that B is the inverse of A, then B is the inverse of A, and we represent it as A inverse, that is equal to B. If B is the inverse of A, certainly A is also the inverse of B. Also, A is the inverse of B in this case. And if we are finding here that A into B is equal to I is equal to B into A, then also we say that A is the invertible matrix. Then A is invertible matrix. When we find the inverse or multiplicative inverse of a matrix, then we find that it is unique. Let's learn how it is. We will prove it that the multiplicative inverse of a matrix is unique. Let A be a square matrix of order n into n, and suppose it does not have unique inverse, it has more than one, suppose there are two. So we consider let B and C be two inverse matrices of A. If B is the inverse of A, do we find that A into B is equal to I is equal to B into A? Suppose it is the first relation. Also we have C as the inverse of A. It means we will have A into C is equal to I is equal to C into A. This is the second relation. Now we know that B can be written as B into I. Can we also write this as B into A into C? Why? Because A into C is equal to I from relation 2. We can write here from 2. Can we write this as B into A into C? Because we know multiplication of matrices is associative. And we know that B into A from the first relation is I. So we can write this as I into C using the first relation. And we know I into C is equal to C. This implies that B is equal to C. It means there can be only one multiplicative inverse of a square matrix, and hence we can say the inverse of a matrix is unique. Now we will learn how to find out the multiplicative inverse or inverse of a matrix of order 2 into 2 by using the elementary transformations. First we learn about using row transformations. To find the inverse of matrix A by using elementary row transformations, we will write I into A equal to A. And what we will do here, we know the unit matrix of order 2 is 1 0 0 1 into A, and here we will write A, that is 2 1 6 4. We are going to use the elementary row transformations, means we will use only row transformations and no column in between. What we do in that case, we will try to make this first element A11 as 1. That can be done by dividing this by 2. So we divide row 1 by 2, we are writing, applying row 1 as half row 1, means we are multiplying row 1 by 1 by 2, and that we will do in both the sides. So we are writing here half 0 0 1 into A equal to, this will be 1 half 6 and 4, and then with the help of this particular element which we have made as 1, we will try to make this element of the same column, that is A21 as 0, and that can be done by using the elementary transformation that subtract the 6 times of row 1 from row 2. So we can apply here, in row 2 we are doing row 2 minus 6 row 1. What we get here, this is half 0, this will be 6 times of this, means 3, we subtract, this will be minus 3, 6 times this we subtract, this will be 1 only, into A, and on this side we will get 1 half, 6 times of this when we subtract, this will be 0, and 6 times of this is 3, when we subtract from 4, this will be 1. Now the second step will be converting this into 1, but here since it has already become 1, we will be using this element to make this element as 0. The main purpose is to convert this into I, into the unit matrix. So what we are applying here now, in row 1 we will be subtracting half times of row 2 from row 1. Then on the left we will be getting, in R1 half of this means minus 3 by 2 we are subtracting, that will be 3 by 2, this will be 1 by 2 plus 3 by 2. Half of this, that is half, subtracting from this, this will be 0 minus half, and this is minus 3 1. This side it will be into A equal to what? This is 1, this is 0, this is 0, and this is 1. Why we are doing this? Because 0 is not going to affect this element, and that's why we will be multiplying or adding or subtracting some multiple of this from row 1 to make it I. Now we have converted this as I. We get here 1 by 2 plus 3 by 2 is 2. This is minus half, minus 3, 1 into A equal to, we can write this as I. And if this is I, means this is the inverse of A. So we can write that A inverse is equal to 2 minus half minus 3 and 1. And this is the answer. This is the way we can make use of row transformation to find the inverse of a matrix of order 2 into 2. Now we will find out the inverse of the same matrix by using the elementary column transformations. For that we will write here A into I is equal to A. And we write here A into the unit matrix 1 0 0 1 equal to A means 2 1 6 4. First step is same. We will try to make it as 1. Now this time we can do it in two different methods. That is, we can divide it by 2 or we can subtract the second column from the first. Subtracting makes it easy without converting into ratios. So we are applying here the first transformation is C1 minus C2, and here we get here A into, that is 1 minus 0 is 1, 0 minus 1, that is minus 1, 0 1 into A, that is equal to what? 2 minus 1 is 1, 6 minus 4 is 2, 1 4. Now with the help of this element, this time we will make this A12 as 0, because we are using the column transformations. So we subtract this here, that is applying, in C2 we are applying C2 minus C1, and we get here A into 1 minus 1, this is minus 1, this is 1 plus 1 will be 2, equal to 1 2, 1 minus 1 0, 4 minus 2 2. And now we have to make this element as 1, that is A22. So to make it 1, we divide it by 2. So we are applying in C2, that is half of C2. And we get here A into what? This is 1 minus 1, this is minus half, and 2 upon 2, this is 1, that is equal to 1, 2, this will be 0 and this will be 1. Now with the help of this element, we have to make this element as 0 to convert it into the unit matrix. So we apply now the operation in column 1, applying C1, that is C1 minus twice of C2 to make it 0, and we get here A into C1 minus twice of this is 1, 1 plus 1 is 2, minus 1, that is minus 2, this will be minus 3, this is minus half, and 1 is equal to C1 minus twice of C2, this is 1, this is 0, 0, 1, it is converted into I, and hence we can say that A inverse is 2 minus half minus 3 1. This is the same answer what we got by row transformation. Now we can verify our answer by multiplying A and A inverse. So we can verify, multiply A into A inverse. A is 2 1 6 4, A inverse is 2 minus half minus 3 1, and when we multiply we will get this as I. This is the verification that our answer is right. Now we will be learning the algorithm to find out the inverse of the matrix of higher order than 2 into 2. In case we want to find out the inverse of any of the matrix of order higher than 2 into 2, that may be 3 into 3, 4 into 4, or any other one, that is n into n, by using the elementary row transformation or column transformation, we are to discuss the algorithm for that now. Say here, suppose we are finding the inverse of any of the matrix of order 3 into 3. Matrix is A, and we have written the elements in the form of Aij, that is A11, A12, A13 and so on. To find the inverse of it, first and foremost the step is, for the row transformation we have to write I into A equal to A, and for the column transformation we have to write A into I equal to A as the statement. The same we have used in the previous question also. The next step is using the elementary row or column transformations on both the sides. On the left hand side we will be using that in I, and on the right side we use the same transformation in A, and we will convert A into I. And we know if this A is converted into I, this will become B into A is equal to I, and then we can say that B is the inverse of A. To do that, what we do, the easiest way to convert this into I and this into B is that we convert first of all this A11 as 1, the unit. With the help of this 1, we can make these two elements of the same column, first column, as 0. Then the next step we will take, that we will try to make A22 as 1 by some elementary transformation. And then with the help of this, we will make the elements of this column, that is A12 and A32 as 0. This is, we are discussing about the elementary row transformations. Then next step we will make this A33 as 1, and with the help of that we will make these two elements of the third column, that is A13 and A23 as 0. And you will find that this has been converted into I. When this is converted into I, then we will get the statement in terms of this B into A is equal to I. And then we can say that B is the inverse of A. The same way we can go for column transformation. In that the only thing is, when we make this as 1, we will be making the elements of the same row as 0, A12 and A13 and so on. We will follow the procedure. And then we can get the inverse of the given matrix. After learning about the algorithm, following that how we can find out the inverse of a matrix of order 3 into 3, let's learn it through one of the example. And that is a matrix A, the elements in which are 2, minus 5, minus 3, minus 1, 3, 2, 3, 1, 3. We will be finding the inverse of it by using elementary row transformations. And for that we know that we have to write I into A equal to A as the first step. I, that is the unit matrix of order 3 into 3. Into A equal to A, that is the matrix we have written here. Now as the first step what we do, we have to make this as 1. To make this particular element as 1, we can use two different transformations. One is, we can divide this by 2. Dividing this by 2 means we will convert these elements into the fractions, and we try to avoid the fractions in the first steps. That is the last option we take, because when we go for the further transformations, I find many times that the students are confused with the fractions while adding or subtracting or multiplying. They commit some other mistakes. So better avoid that. But in case there is no option, then we have to go for it. Here we apply that interchange of R1 and R2, applying the interchange of R1 and R2. What we get here? This will be 0, 1, 0, 1, 0, 0, 0, 0, 1 into A. And on the right side, we will have minus 5, 3, 1, 2, minus 1, 3, minus 3, 2, 3. Now to make this element A11 as 1, we can add 3 times of 2 in this so that it becomes 1. So what we will do, we will apply here in R1, that is in row 1, that row 1 plus 3 times of row 2. Then what we get here? We are getting here 3 times of row 2, that is 3, 1, 0, 1, 0, 0, 0, 0, 1 into A is equal to minus 5 plus 6 is 1, 3 minus 3 is 0, and 1 plus 9 is 10, 2 minus 1, 3, minus 3, 2, 3. Now to make these two elements 0, what we will do? We can apply the transformation, that is twice of row 1 we can subtract from this, and thrice of row 1 we can add in this. So we are applying in row 2, we are applying row 2 minus twice of row 1. In row 3 we can apply row 3 plus thrice of row 1. And then what we get here? On the left side we are getting 3, 1, 0. Twice of this we are subtracting. 1 minus 6 is minus 5. 0 minus 2. And this is 0. Thrice of this we are adding in this. That is 3, 3, 9. This is 3 and this is 1 into A equal to 1, 0, 10. Twice of this we subtract, this becomes 0. This is minus 1 and this is 3 minus 20, that is minus 17. 3 times we are adding in this is 0. 3 times of this, that will be 2. 3 times of this, 30 plus 3 is 33. Now we will make this as 1. A2, 2 we are making 1. For that we can multiply R2 with minus 1. So we can apply here in row 2, that is minus row 2, multiplying with minus 1. And we are getting here 3, 1, 0, 5, 2, 0, 9, 3, 1 into A equal to 1, 0, 10, 0, 1, 17, 0, 2, 33. And now with the help of this we want to make these two elements 0. This is already 0. So we have to apply transformation only in the third row, and that we can do here applying in row 3, that is row 3 minus twice of row 2. When we do that here, we are getting here 3, 1, 0, 5, 2, 0. Twice of this. 9 minus 10 is minus 1. 3 minus 4 is minus 1. And this is 1 into A equal to 1, 0, 10, 0, 1, 17, 0. Twice 2 minus 2 is 0. 33 minus 34, that is minus 1. Now we have to make this element as 1. And for that what we will do? We will multiply third row by minus. So what we are doing? We are multiplying row 3 with minus 1. Applying the transformation in row 3, that is minus row 3. And here we are getting 3, 1, 0, 5, 2, 0, 1, 1 minus 1 into A equal to 1, 0, 10, 0, 1, 17. It is 0, 0, 1. With the help of this we have to make these two elements 0 now. And for that what we will do? In R1 we will be doing R1 minus 10 R3. And in R2 we are applying R2 minus 17 R3. What we get here? 3 minus 10 minus 7. 1 minus 10 minus 9. 0 minus minus 10 means plus 10. Here it is 5. In R2 we are doing 17 times of this. 5 minus 17 is minus 12. 2 minus 17 is minus 15. And 0 minus minus 17 means plus 17. This becomes 17. This is 1, 1 minus 1 into A. And here on this side we get 1, 0, 0, 0, 1, 0, 0, 0, 1. So we are getting here this B into A is equal to I. Then this B is A inverse. Therefore B, that is A inverse, is equal to minus 7, minus 9, 10, minus 12, minus 15, 17, 1, 1, minus 1. And this is the answer. We can verify this also. We multiply this A inverse with A, and if we get I, then we can certainly say that our answer is right. We can also do the same question by using the elementary column transformations. The same answer we will get for this by that particular method of elementary column transformation also. In the next video, we will learn about the applications of the matrices in different type of problems. In that we will solve some of the special problems on matrices, and also we will go for word problems. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.